Okay, here is my work. So for the model, I divided the data between the training data and the test data. For the training, I use around 70% for training, and then the remaining 30% for the test. As you can see here in the training set, I use around 6,000 lines of data, and then the test set, I use the remaining around 3,000 data. And then for my model, the model I use two models, Model 1 and Model 2. And then the difference between Model 1 and Model 2 is whether I include the humidity factor here, because I did the correlation of each input with the final output. As you can see here, the temperature vacuum are highly negative correlated with the output. Pressure is positively correlated with the output, while the humidity the least correlated. So in my Model 1, I use all the four inputs to run my linear regression. And as you can see here, the multiple square, the R square is actually 0.93, which means the model can highly explain the whole outcome. While in Model 2, I run the model with three inputs: temperature, vacuum, and pressure. I didn't include the humidity. And as you can see here, the R square is around 0.91, now 18. So which means the model it still can explain the output, but it's less um, explains less compared to the Model 1. So in that regard, Model 1 is better. So once I have the model, so the intercept or the coefficients, I applied all those factors into the testing set, test 1 and test 2. And I calculated the error between the actuals and what we predicted. And here you have the summary here. So this is the median standard error and the median absolute error. As you can see here, I think both models can have a relatively small errors, and so that means our model actually works.